Welcome, everybody. I'm Vikram. I head product management for all our language services at AWS. And today, we're going to be talking about building intelligent applications with Amazon Machine Learning's language services. So let's start with the entire machine learning stack that we have at AWS. So we have 3 layers to the stack. At the bottom layer, we have tools for data scientists that want to do everything by themselves. So we've got all the different frameworks like TensorFlow, Gluon, MXNet, and so on, with all the GPU instances. Right above that, we have the platform layer, which is for data scientists. They want to focus on the algorithms, but don't want to do the infrastructure part of it. So we've got what we call SageMaker that makes it really easy for you to train, build your algorithms, and then test them, and then deploy them. And at the top layer, we have what we call as application services, which are API-based services, where the developer doesn't really need to know anything about machine learning. All they need to know is what they want to build. They just have a smart idea. They want to build an application, and they can do so using these API-based services. And we're going to be focusing on all the language-based services in that space. So we're going to be talking about Transcribe, which is our speech recognition service, Translate, which is our machine translation service, Poly, which is our text-to-speech service, Comprehend, which is natural language processing, and Amazon Lex, which is our platform to build conversational interfaces. Let me just give you a broad overview of all the different types of use cases that we're seeing customers use our services for. So we're seeing these services being used for voice of customer applications, where you want to understand what your customers are saying about your business and your brand. In call centers for IVR and analysis of the phone calls. As digital assistants in the enterprise for employees, where if they have questions about vacation policies or HR policies and so on, you have a bot that can answer all that. Personalization in the media space, where publishers want to know what sort of articles you like to read, and based on that, they recommend your next article. Knowledge management, where folks that have a lot of text are able to organize their data and query that more easily. Semantic search, again, by using things like Comprehend and indexing on key phrases and entities, you're able to get much better search results with Elasticsearch. Captioning in the media space, where you can add subtitles to videos. Localization with translation, where if you have content, you can translate it into many different languages and make it localized for your audiences across the world. In the education space, especially things like Poly, which is allowing you to speak out prompts and make suggestions and give that interactive learning experience. To improve accessibility with subtitles and closed captioning, as well as by voicing websites. And also informational chatbots, which give you information about things like scores and so on. So let's start with how do you make your applications conversational? To help you, we built what we call Amazon Lex, which is a service for building conversational interfaces into any application using both voice and text. With Lex, we brought together many critical components. So we start with what we call speech to intent, right? So we go first from speech to text using speech recognition, and then from that text to the intent. So we call that speech to intent. Along with that, we have dialogue management, which figures out the information that the customers have given so far and figures out what the next prompt should be and how it should interact with the customer, how to handle errors, and so on. Easy deployment to many different platforms. So whether it's Facebook or Twilio or for your SMS, you're able to deploy it with a few clicks. Scale. You don't have to worry about provisioning servers. What if Suddenly, I have a lot of traffic on my chatbot. We take care of it for you. Integration with business logic. So Lex gives you the conversational interface where it identifies what the customer is saying in terms of the intent and what data they've given you so far. But then you actually need to take action on whatever the customer asks, which is your business logic. So we integrate with Lambda, where you can write your business logic, and with one click, integrate that into your Lex bot. Security. So with a lot of these new technologies, there's a lot of startups and so on, where security is one of the last considerations, but for AWS, that is the first consideration. So security is a really important part of Lex. So we integrate with Cognito, so you can set up your users and add authentication to your chatbots. Analytics. So with machine learning, you don't get things right the first time. So what you do is you go out with your best estimate of all the different intents that your customers might express. But then your customers may be expressing themselves differently or asking for entirely different intents. So you want to know what input is coming to your bot and keep improving that chatbot. So we got analytics for you to do that. And finally, integration with Poly for your text-to-speech so that you can speak things back to your customers. A few things that go into a good bot are social intelligence, personality, modality, and dynamic conversation. And today, Lex has features that enable all these different capabilities, from integrating with Lambda, where you can go and fetch user information from your backend systems, to providing you multiple prompts so that you can give your bot a personality, different tones in the Poly voice, where you can pick the personality of your chatbot, error handling, and so on. Some of the use cases for Lex are contact center chatbots, where we see a lot of customers replacing their existing IVRs with Lex. So we are integrated with Amazon Connect, which is our contact center in the cloud. So all customers have to do is open up the AWS console, set up their phone number, their call flow, integrated with their Lex bot, and in an hour or 2 hours' time, you have your entire contact center set up in the cloud. Whereas if you went to a traditional provider to do this, it might take you weeks, months to get this set up and to even get a quote. Other use cases are informational bots, application bots, where you can do transactions, productivity, where you can ask things like, what's the latest on this account, and so on. And IoT is another use case we're seeing as well. So how do you give your applications a voice? So we just spoke about Amazon Poly, which is our text-to-speech service, which converts text into lifelike speech. It has more than 50 voices and more than 25 languages. And we see the most often, the use cases that we are seeing with Poly are content creation in mobile and desktop applications, IoT use cases, education, telephony, and game development. Some of the customers that we're seeing for Poly are in the space of navigation, assistance. Like I was saying, it improves accessibility for folks with special needs, creation of videos, announcing prompts over the radio, podcasting, as well as notifications in the IVR use case. Now let's talk about how you extract insights from unstructured text, right? So think of it as an ability to read every single blog, every single tweet, every single email that people are sending you or writing about your company, and knowing exactly what your customers are thinking about your brand, your product at any point in time, right? Just imagine how many people you would need to employ to do that sort of a thing. But with Comprehend, which is a fully managed, continuously trained service that helps you extract insights from unstructured text, you can do that with a few dollars. So today, the features that we support with Comprehend are sentiment analysis, where you can pass some text and figure out whether the sentiment is positive, negative, or mixed. Entity extraction, where you could extract entities like organizations, names of people, dates, locations, and so on. Key phrase analysis, so things like beautiful views, or a great book, or great prizes, and so on. Languages, so we do language detection, so we detect more than 100 different languages. So if you have emails coming from across the world, you want to know what language that email is and route it to the right agent, you can do that. We have topic modeling, where if you have a corpus of documents and you want to know what are the common topics that these documents are referring to, you could run it through topic modeling, and it'll show you output in terms of topic 1, topic 2, topic 3, and describe all the words that go into that topic and also all the documents that contain that topic. And today, we're also launching a new feature, syntax, which allows you to extract parts of speech. So here's an example. So if you have text, Amazon.com is located in Seattle and founded by Jeff Bezos. You pass that through comprehend. The output looks like what you see on your right. You can see all the named entities like Amazon.com, organization, Seattle, July 5th, Jeff Bezos, and so on. All the key phrases, our customers, great prizes. The sentiment is positive because we're saying they love buying everything at great prices, and the language is English. And the way the parts of speech capability, which we're calling the syntax API, works is, let's just take that small string of text that we had before and pass that through the API. You get the word boundaries, which is each word, and the starting character and ending character, as well as the part of speech of that word. For example, customers is a noun, love is a verb, books is a noun, great is an adjective, and so on. So really useful if you want to dig deep into text and understand, OK, this sentence had a positive sentiment, so what were the things that folks were talking about in that particular sentence, right? So what was the pronoun, what was the adjective, what was the noun? Some popular use cases are content personalization. So if you're a media house and you know that a particular customer read about 5 articles or 10 articles, you could extract all the entities from it, cluster them, and find out that, OK, they're interested in this particular sports star or player, or they're interested in this particular topic. And then you're able to recommend further content that's really interesting to that customer. Semantic search. So if you just extract all the key phrases and index them, your search on Elasticsearch is going to become so much nicer and gives you a better experience for your customers. Intelligent data warehouse. So you're able to incorporate comprehend into your ETL workflows so that you can just query blurbs, let's say, from a column in your data warehouse, run sentiment on it, and insert sentiment into another column so you know exactly what the sentiment is for each blurb. So you could run queries on it saying, count the number of comments that had a positive sentiment, and you're able to analyze all that data. Social analytics. So you're able to easily hook up Twitter with Kinesis and then pass that through comprehend, extract all the entities, the sentiment, put that back into S3, and using Athena and QuickSight, which is our visualization service, you're able to put up really nice charts and dashboards that indicate what customers are saying, drill down based on specific entities, drill down based on sentiment, filter based on sentiment, and analyze your voice of the customer. This sort of shows you all the different tools, AWS tools, that you can use, AWS services that you can use along with comprehend in order to achieve the various use cases. So when you have streaming sort of use cases, you would hook it up to Kinesis. You would do search with Elasticsearch, your data warehouse with Redshift and Aurora, and things like clustering on EMR. Now let's talk about how you can make your applications listen. Because the amount of audio data that's being generated and stored is increasing exponentially, right? And there's no way of extracting any reasonable intelligence from audio because it's so hard to process digital audio. What you need to do is first convert that into text, because once it is in text, you can extract things like customer insights, you can do things like closed captioning, and the possibilities of what you can do with it increase. So we launched what we call Amazon Transcribe, which is a fully managed, continuously trained automatic speech recognition service that takes an audio and generates a text transcript for you. You will notice that I stress on the words fully managed and continuously trained. The reason is that for all these services, we've invested a lot in this continuous improvement, right? Because with artificial intelligence and machine learning, you need to continuously keep training in order to keep up with changes that are happening in the language, as well as to keep increasing the accuracy to handle difficult use cases like noisy audio or far field microphones where speaker is not close to the mic and the quality of audio is not so strong, and so on. The features that we have today with Transcribe are ability to detect multiple speakers, where we can say speaker 1 said this, speaker 2 said this, again speaker said this, speaker 1 said this, and so on. Custom vocabulary, because no matter how accurate our speech recognition is, you're always going to have terms that are specific to your domain, whether it's insurance or finance, that maybe the speech recognition engine doesn't get right. So you can load those words up as a custom vocabulary to bump up the accuracy for your speech recognition. We support a wide range of audio quality, and we're especially accurate on low-quality telephony audio, because we know that a lot of our customers are sitting on millions of minutes of telephony audio that they've recorded, but they're not able to analyze because it's cost prohibitive. So we've taken a lot of pain to train specifically for 8 kilohertz audio, because on the telephone line, not all the information you're able to store, so the sampling rate is 8 kilohertz versus 16 or even higher for other sorts of audio. We are integrated with Amazon S3, so if you have all your files on S3, you just point Transcribe to your files, we generate the transcript, and just a couple of weeks ago, we launched a new feature where you can also specify the S3 bucket where we should put the transcripts in. So we'll just put that back into your own bucket, so it's completely secure. You own the data. Timestamps and confidence scores. So we're able to give you timestamp for every word, as well as the confidence score. So if you have workflows where, let's say, closed captioning, where you want the text to be perfect, so you would take the output from Transcribe and then give it to a human, and then they could focus just on the low-confidence words so that the time they take for post-editing is drastically reduced. Punctuation. Again, there's a lot of engines out there that gives you just plain text. We give you punctuated text, which makes it much more easy to read and consume that text, right? When you have full stops and capitals and so on. We support both English and Spanish. And today we're launching availability in 2 additional regions, Sydney and Canada. So if you have customers in those countries and you would like to use a service that is local so that the data is stored locally, you can get started using Transcribe in those regions. Here's some of the use cases that we're seeing customers use Transcribe for. Call centers. So you have thousands of customers that are calling into your call center. Your agents are taking those calls. And all of you might have experienced these calls where they say this call is being recorded for quality assurance purposes. But how often do you think a person's actually sitting there listening to those calls and reviewing what happened in each call, right? It's humanly impossible to sit and listen through millions of minutes of phone recordings. So what we do is run it through Transcribe, get that into text, and then you could run it through Comprehend to extract the sentiment, key phrases, and entities, and then analyze it to do things like churn analysis and measure the effectiveness of your agents, agent coaching, and so on. Subtitles and closed captioning. So if you have videos, if you're a media company and you want to add subtitles, Transcribe reduces the amount of effort and time required to add those subtitles by giving you a really good transcript to start with, so that your human folks that are actually doing the post-editing don't have to spend a lot of time fixing the errors. And some more use cases that we're seeing are meeting transcriptions, where customers in the financial industry, they're recording all their meetings. They want to set up an archive of those meetings, be able to search through it. Legal use cases where you have court proceedings that need to be transcribed and made available to lawyers so that they can search through the archives. Here's sort of the architecture of how you would set up things with Transcribe. So your audio input, you would put into S3 using Lambda. You would invoke Transcribe on that audio, get that text, then run it through Comprehend, place it back into S3, and using Athena, which is the service that allows you to query data that's in S3, you would get that into QuickSight for visualization. And the last service that I'm going to talk about today is how you make your applications multilingual. Because research has shown that when you're trying to sell to customers across the world, they're more likely to buy your product when you talk to them in their language. And when they have trouble with the product, they prefer to talk to support, again, in the language of their choice. Also, you have many global companies that have employees across the world, and not everybody may have the same proficiency with English or whatever the major language of that company is. But Translate helps you bring people together. So Translate is our fully managed, continuously trained neural machine translation service that translates text from one language to another. So today, we launched 6 more languages. So totally, we have 12 languages or 24 language pairs. We translate text input in real time. So you could use it for use cases like chat translation and so on. We are integrated with Comprehend, so you could do things like language detection. We provide easy-to-use SDKs so that you could just integrate Translate into your workflows. In fact, the social analytics workflow I was mentioning, you would have tweets in other languages too, right? So like right now about the summit, there's probably folks tweeting in Spanish, in French, and so on. And what you can do is translate all those into English and then pass that through Comprehend so that you can see one common dashboard. AWS security standards, again, I would stress that for all these services, security is the #1 priority. So we make sure that your data is safe. It's available in multiple regions. And it's priced very cost effectively so that you can use machine translation at scale. So that's the one thing that has changed over the last couple of years, where before, the quality of machine translation wasn't as high, because folks were using older technologies like what we call as a phrase-based translation, where you literally take each phrase and translate it. But what we do with Translate is we use something called neural machine translation, which is the state of the art, which takes the entire sentence and with this context, it translates that into a new language. So as the accuracy of machine translation improves and comes closer and closer to human-level accuracy, the things that you can do with translation become really amazing, because imagine the chat use case, right? So if you have I don't know, 5,000 employees spread across the world. They're all chatting, and you want to give them an experience where they can chat in the language of their choice. So your German employees can just type in German, and the folks in the US can just type in English. And each language gets translated to the language of choice so that you're still reading the other person's messages in English. I mean, this would not even be possible with a human in the loop, right? So these new use cases of translating at scale are enabled by machine translation. So the languages that we support, so currently we're already supporting Arabic, Simplified Chinese, French, German, Spanish, and Portuguese. And today we're launching support for Japanese, traditional Chinese, Italian, Russian, Turkish, and Czech. So we're moving at a really fast pace, and we're investing in all these services. So as you can see, we made these announcements at S4 Summit where we went GA with Translate with those 6 languages. We already added 6 more. So we're going to continue to be aggressive in investing in these services and keep adding newer features and more languages. Talking about use cases, we see machine translation as the the service that can be used in use cases where you have language that needs to be translated at scale, right? So you're always going to have that small number of legal documents or healthcare documents that need 100% accuracy. Not one word can go wrong. But even there, you can have machine translation come up with the initial translation and then have a human go ahead and fix any errors. But for things like user-authored content, chat transcripts, for text analytics, where you want to analyze, let's say, every news article across the world in 10 different languages, looking for articles on the blockchain or something like that, so because you're doing some analysis. And you're able to do things like that because translation helps you bring everything into one language and then run that through things like Comprehend, which will extract all the information from that text for you. Real-time communication, we already spoke about chat. In fact, we had a really cool demo where on Twitch, we implemented a translation where you could join a certain chat room, and you could just start chatting in your own language of choice. And all the other languages would get translated into your language that you picked. And content discovery, like I was saying, you can discover content in new languages. You don't need to know what blockchain means in, or the word for blockchain in Portuguese. You can just search for it, and Translate will figure it out. So next up, I want to show you how customers are using our services in the wild. And we have a really cool use case from OneCall that also uses our partner PubNub. So to introduce this use case, I'd like to invite on stage Casey Clegg, who's the VP of Sales from PubNub. So, Mike.
All right. Hi, everyone. Thanks, Vikram. So, guys, I wanted to talk through a little bit about the apps that we're using today. So a lot of what we're using as consumers in business as well is real-time. We're expecting real-time communication, real-time reactions to what we're doing. The services, the games that we're doing. It's all based on this real-time concept. And really a lot of what things like Amazon Poly or Amazon Comprehend are allowing us to do is take that further. So allow us to push into these applications real comprehension on what consumers intend. So the use case that OneCall put together and that SourceFuse put together for them is a great example of this. I'm really excited to show you guys this a little bit later. But a few things on this. I think it's important just to take a step back and think about what is required to put together a real-time application. So first, it has to be scalable, it has to be reliable, but the other side is, and what we're finding more and more at PubNub, is it also needs things like machine learning, things like what Amazon ML is allowing access to. And the reason for that really is at base, I mean, if you think about what PubNub is really three things. What we do, and I think it's important to understand in the context of why we're seeing so many customers demanding services like Amazon ML. But we really do three things. One is connecting devices. So across Android SDK or iOS or IoT device, we have over 75 SDKs that allow you to maintain a connection to devices. The second thing is delivering data to those devices, ensuring that data can flow between or from your service back to those devices. And the third thing is reacting to that data, allowing you to see what's going over the chain and actually in real time make decisions on whether you're going to kick off an asynchronous process or change the data in process. And that's a lot of what we're seeing across the trillions of messages that are going over our network, the thousands of customers that we have on the platform. What we see is those customers need to access things like Amazon L, things like Amazon Poly or Amazon Comprehend, so that they can better serve their consumers, their customers in process. And I think it's really just important to think about the questions that come up when you build these things. How do you actually host a chatbot? How do you kind of make sure that you can convert speech real time and actually interact with that consumer through the application? And PubNub allows a way to do that through our partnership with AWS. And what I want to do is bring up Kelly Dyer, who's going to talk through how they reacted to a business problem and put together a solution that allowed them through PubNub and Amazon ML to come up with something that is really a great solution for one call. So I'll bring up Kelly now.
Thank you. So I'm just going to give a quick introduction about us and the real world kind of example of where we've applied some of these things and kind of where we're going with it. But before I introduce there, just a quick word about us. I'm CEO of SourceFuse. We're a global team of about 150 people, and we're product builders. And what we do is we like to work with organizations to find those untapped opportunities and come in and be able to apply startup practices to the enterprise. So agile releases, leveraging new technology, and best-in-class services like all the AWS suite, like PubNub, and put these to work to solve real-world problems based on data and outcomes, and iterate really quickly on those. And so that's how we do it. And so now what we're going to do is I'm going to introduce one real-world example of that, a large organization that we've been able to help apply some of these things. And you can hear about the business case where that comes from, and then some of the specific technology implementations we've already done that are in production, and then kind of where we're going with it to apply some of the Amazon ML and these other services to have further gains and real-world results. So the company is OneCall, and Joe McCullough, Executive Vice President, is going to kind of lay out kind of what they do, and then Kabir from our team will talk about kind of how we solve some of those problems. So Joe McCullough, OneCall, here you go.
Thanks, Kelly. Good afternoon. Hopefully what it can do today for you is really kind of bring everything you've heard so far, kind of demonstrate that in a business case. My job at OneCall is a Senior Vice President of Product, specifically around the development. So basically it means I get to think of all the really cool things that we could potentially do, and then go to folks like Kelly and PubNub and Amazon to say, how would we do this? So what I want to do today is kind of show you what we did. Before that, I'll tell you a little bit about OneCall. Important to understand that we are the #1 market leader, specifically in the workers' compensation market, across several different verticals we'll get into. #1 in revenue. If you combine the revenue of our competitors, we'd probably still be more than they would in aggregate. The verticals we have across these 6 range from diagnostic services, MRIs, all the way down to doctor and dental. We're going to specifically today kind of concentrate on transport and translate, which kind of nicely go into the things we've talked about. The transport translate vertical has been around for over 2 decades. Most of all these we refer to these as an ancillary space in healthcare. And while we definitely focus on the workers' compensation aspect, what we also are getting ready to launch into other healthcare adjacent markets as a result of the technology and what we've built today around the transportation translate piece. So a little bit about the business case, transportation. As you can see, transportation in healthcare is a problem, specifically as a social determinant, and is one of the things that you can actually control. We have clients that it's not unlikely that they have upward of 30+% missed medical appointments. What's the problem? The problem was typically you only had transportation in use if you were transportation dependent. But what if you actually could use transportation to drive down those missed medical appointments? So there is a consciousness shifting in the marketplace that transportation is not just an expense. It's actually a cost avoidance factor that you can layer in. That 10 billion of missed of that 150 is directly attributed to transportation. But as I said, as a shift in the marketplace, people are saying maybe it's better to use the transportation and pay for a $25 ride to be sure someone gets to a dialysis appointment. So what did it look like before in transportation? Typically, it would go something like this. Patient needs a ride, calls the contact center, agent answers the phone, says, yes, 2 p.m. tomorrow, Mrs. Smith will be ready to take you, hangs up the phone, enters some information into the system, picks up a phone, calls a transportation provider, maybe the contact center's in Atlanta, calls a transportation provider in Jacksonville and says, can you take Ms. Smith to her appointment tomorrow at 2 p.m.? Transportation provider says, certainly I can do that. Great, it's booked, we'll all keep our fingers crossed and hope it works. I might call the transportation provider tomorrow, make sure you're still gonna pick up Ms. Smith. Yep, I've got it. An hour goes by, 3 o'clock, Ms. Smith's not picked up, picks up the phone, calls the transportation company or the broker would then call the provider, where are you? I'm only 10 minutes away. Maybe they get Ms. Smith there, and then she's stranded for 3 hours later waiting for a return ride. That's notorious in the healthcare market for transportation. Nothing was real time. Providers have trip logs, electronic signatures they have to collect, missed appointments. Imagine a missed appointment to a dialysis treatment. So the consequences are very real. So what we came up with is, wouldn't it really be cool to have real-time visibility in the transportation rides? How do you do that? What we did is we, at the time, a couple years ago, said, what if we integrate it with Lyft? Tapped into their health API, could actually dispatch that ride real time, actually could get alerts real time, tell the patient who's picking them up, what the car looks like, the license plate number, the ETA, and when they need a return ride, call us or click a button, reply in an SMS text through a workflow, and we'll dispatch the ride immediately for you. So we actually have agents real time monitoring those rides, and the key word is real time. And most of the time I have to tell everybody, stop watching the cars go around, the alerts will take care of it for you. And when things come off the rails, we can actually intervene. What does that translate it into? We have a stat called unable to performs. And unable to performs are really something, meaning something happened. We had something scheduled. And they actually take place in metropolitan areas. We've seen an 80% improvement in the unable to performs when we use this solution, because we have the real-time visibility. A driver cancels, no big deal, we can dispatch another one. You're gonna be late to your appointment, not a big deal. We can call the facility, let them know, and make sure you can still be seen. So the impact is very real. We've been using this program for about 1.5 years now, so it's real data. And as you can see there, a couple 100,000 rides, over 400 health clinics using Relay today. Average ETA, the 8 minutes, 13 seconds, and the cost, a little under $25. So this is data that our customers find very helpful. Comparatively, we can monitor the rides before, not monitor, but we could tell you how many you had in a year. I could not tell you what's the average waiting time for your patient to be picked up. I can give you an average cost, but not down like I can today. And so what we've seen through the health clinics using this is that they've actually really been able to impact their no-show rates. there are no-show rates are, of course, associated with their revenue. So it's very advantageous for them as well. So hopefully that gives you a little bit of an idea of what we've been able to do with the transportation, the real-time piece of it, as well as what Kabir is going to be speaking to about the translate piece, and how we kind of came across a use case to give it even more detail. So with that in mind, I'll turn it over to Kabir. Thank you.
Thanks, Joe. All right, so sticking with what Joe basically left us with was two key components, right? He mentioned real time, at least 10 times. So that's key to getting these people to their doctors on time. And the second thing is communication, right? Every step of the way, you've got to keep the patients, the drivers, everyone involved updated on what's happening. So which is why this was really a good, an ideal synergy of the two technologies that we've talked about, right? So we talked about Amazon's machine learning services, Poly, text-to-speech. We talked about Lex, conversational bots. We've talked about Translate, for obvious translation services. And then we talked about PubNub, which is the real-time messaging framework. Now, put both of those things together, and what you get is really massive efficiency for these kind of operations. So before I actually dive into what we actually ended up building for OneCall, just like to go over a brief architecture of our application. So what you saw on this screen, really, those are the sort of agent portals that agents at OneCall use to sort of orchestrate, book rides, facilitate them, helps them keep updated in real time on what's happening on the ride. There's geolocation of the actual Lyft ride happening, on that second screen. And on the first one, you can see there are a bunch of, red, amber, and blue alerts, which basically is telling agents that, the patient might be late, or, the driver canceled. So essentially, what's happening is agents are being updated in real time and are able to take corrective action to make sure that the patient actually gets to their appointment, on time. So, brief architecture overview. We started off, with a typical monolith, a couple of years ago. As the application and the platform got sort of absorbed into the enterprise, scaled nicely, at which point of time we started moving towards a more microservices architecture. As we added more providers, as we added customer integrations and so forth, and as can be seen here, key components is really the PubNub piece feeding into both actually agents on the OneCall side as well as patients. So what's important here to mention is that this is really an omni-channel solution, right? So what we're trying to do is give this service, across demographics, across all ages, across people that are high tech, low tech, access to mobile phones, maybe just feature phones, and so forth. And then we obviously have big audit log database that we use. Our sort of data team uses to figure out how we can improve patient outcomes, and what are those features that we can introduce to improve the system. And then lastly, we obviously have the AWS Connect, and Poly integration that we'll speak to right now. All right. So what was the problem really? This is the problem statement, what was happening before. So obviously after, like Joe said, after the system was introduced, there were massive efficiencies in getting patients on time, a lot of cost savings, a lot of automation, and it was great. But when we dug into the data, we actually saw that there was a certain section of the users, the patients, that were still missing or getting late for a lot of appointments. So schedule adherence, getting to the doctor's appointment on time was still a problem. When we dug deep enough, we realized that these patients were still using landline phones, right? So important fact is that just over 50%, I think it's 50.2% of all US households are still non-wireless homes, right? There's still a lot of landline usage these days. So, I mean, the problem was clear. We just needed a solution. So, and AWS ML services were basically just coming out at the time, and it seemed like a perfect fit. So what you can see here is what used to happen was the system used to send the SMS text, but they were never really delivered. Hence, the patient never got the information that the appointment was booked for them. The patient never got the information that the taxi was actually reaching their house, say in 20 minutes. Hence, they either missed their appointment or they were late for their appointment, and obviously, unfavorable sort of patient outcome. So what we did was we replaced the SMS text sort of workflow for these kinds of patients with sort of the AWS Poly workflow, right? So what we did with that was we'd use AWS Connect, which is their call center in the cloud solution. And what's great about that is you don't need to provision any infrastructure. It's your DevOps team can basically roll that out within hours. And you plug in the Polyflow, and what you're able to do is then make automated phone calls to patients, who traditionally would not have even received those messages, and keep them abreast on what's happening. This is your appointment. You got to be ready at this time. The taxi is coming to your house in 20 minutes, and so forth. So you can see over there. There's an example of one of the calls that we make. So this is an automated phone call from Relay Solutions. Your transportation has been arranged, and we tell them all about this is your Lyft driver. He's coming in a red Fiat. He's going to be there in 10 minutes, and so on. So a lot of anxiety and on the part of the patient has now been reduced. He knows that someone's on the way. They're going to reach their appointment on time, which is really meaningful impact, right? So what you've got to realize is a lot of this, so these are worker compensation cases. A lot of these are injured workers, that may have limited mobility. If they can't get to their appointment on time, it's going to cause a delay in, them finally getting better and so forth. So the next slide is actually going to show us a couple of example calls that we make. So you can see, in the white box is an example. It says, "Good morning, Kabir. This is an automated call from Relay Solutions. Your transportation has been arranged by one call on behalf of, whoever one call's customer is. Date and time, and you'll receive the details of the driver when you pick up. If you need additional help, you can just call your agent like you traditionally did. And come the time of the appointment, the person gets another call on their landline telling them, this is another automated call. Your Lyft driver, Jamie, is on his way. He's coming in on a Skoda Octavia. This is his license plate, and he'll be there in 3 minutes. So all of that sort of has been taken care of in an automated fashion. And I wish we could have heard the call, but on the right side of it is essentially the SSML, which is the speech synthesis markup language that we use to sort of make these calls. So it's not. So the good thing about Poly is it's just not. You don't give it a string and ask it to convert it to text. It's quite rich, in its feature set. So you can ask it to punctuate. You can ask it to emphasize on words. If there's a sort of colloquial pronunciation for certain words, you could take care of that as well. You could do things like, even breathing sounds, whispers, but not that you want to get into this because you've sort of established it's an automated call. But really, what we're going to see next is that the business results, right? So what we've seen over the last 3 weeks, and the brilliant thing about it is that we were actually able to roll this out in our 1 week or 2 weeks agile sprint, and it's been in production for only 3 weeks, and already we've seen a 10% improvement in schedule adherence for this demographic, which is huge, right? So it essentially means favorable patient outcomes, which is a massive impact, right? So 20% rider satisfaction and cost savings. Now cost savings for one call, because every time there's a missed appointment, your transportation provider will obviously charge you for a no-show, right? So that has obviously drastically gone down. So it doesn't stop there. So like I said, we try and use these sort of best-in-class solutions to solve real-world problems. That's why we partner with people like PubNub and AWS. So now that this use case has been implemented, it's out in production. Both sides, the enterprise and the customer, are now sort of warming up to these kind of solutions, and they're comfortable using them. So what we're going to do next is pick up more use cases where we can bring in this sort of automation to drive efficiency. Now, we're not taking away from what agents do. We're actually making them more effective, right? So one of the use cases that we saw, like 40% of all outbound calls that these agents were making were just to make sure that people have been indeed dropped off at their desired location, right? So here's another use case where we use PubNub and these services together. So as soon as someone's dropped off, and they're dropped off, say, half a mile more than their desired location, the agent will get a ding on their desktop and saying, that's a variance issue. Something went wrong. Your patient is not where they should be. So what the agents typically do is they'll pick up the phone and call the patient saying, are you all good? Did you actually end up at your doctor's, or did the driver drop you somewhere else? Now, please remember that if they were dropped somewhere else, that's a big issue, right? Some of these guys have limited mobility. They may be on crutches. They may be using a walker. So not only patient suffering, but it can cause serious litigation issues for everyone involved. So what we're going to do is basically automate this flow as well. So this one's going to, in fact, integrate with Poly, Connect, and Lex. So the automated call is going to go saying, this is another automated call from Relay. We noticed that you may not have reached your desired location. Are you sure you're at the right place? The person just replies, with a simple yes. If it's a yes, great. The issue is resolved. If it's a no, then we patch in an agent, and that's where the value of a human really comes into the picture, where they actually take care of that issue and then help the patient out. So that's really sort of the value of these kind of services. And the brilliant thing about it is the underlying tech is so high tech. It's artificial intelligence, machine learning, these fancy algorithms, but we're really using it to solve issues for the lowest tech demographic, right? Now, these are people who are actually on landline phones. Now, considering that we made an omni-channel solution, the first, the reaction is to build an app. Now, everyone knows apps have, adoption issues. So what we did was we learned from that and basically, set up an SMS workflow, which works great. 80–90% of the time, it's a brilliant way to sort of orchestrate, these kind of rides, and appointments and such. But really, if you want this to be an inclusive solution, right, and you don't want any part of the demographic to get left behind, you need to sort of incorporate all these sort of high-tech tools out there, really, to do the job. So, yeah, thank you.
Well, that's all we have for you guys today. Thank you all for coming. We'll be around to take questions. So if you have any questions, please come over, and we'd be happy to answer any questions you have. And don't forget to take the survey. Thank you.